number 2. When a flat plate is connected to a gusset plate. So this problem is different from our previous problem. In that model, we have found the design strength, but in this case, we need to find the effective length when a flat plate is connected to a gusset plate. So this is a flat plate which is connected to a gusset plate. We know the design strength, but we don't know what is effective length here. At what length we need to weld the flat to the plate. But we are having the width of the plate and the thickness of the plate. So let us see what are the steps that are involved in solving this problem. So step 1, size of the flat, that is B into T. B is nothing but breadth of the plate, that is from here to here, and for every plate it has its own thickness. So B into T is the size of the plate. Step 2, tensile strength of the plate, tensile stress of the plate, that is Fi Newton per mm square or Newton per meter square. This will be given in the question. Step 3, design tensile strength in the plate. So before finding tensile strength in the plate, let us find the strength of the plate, that is B into T into phi is the it is tensile strength of the plate. For this, if you multiply with 1.5, for the whole equation we get design tensile strength of the plate. So design tensile strength of the plate. Step 4, ultimate shear stress. Ultimate shear stress, it is denoted with F suffix u. It will be given in the question itself. Step 6 is, or step 5 is, design shear stress in the weld. Design shear stress in the weld, that is FWD is equal to FU by 1.3 into partial safety factor. The last step is step 6. Last step is step 6, that is design strength is equal to 0.7 into size of the weld into L effective into FWD. But in this particular case, we don't know what is the size of the weld. So directly we can write size of the weld, that is size of the weld S is equal to thickness of the flat minus 1.5. It must be greater than or equal to 3 mm. Must be greater than or equal to 3 mm. So we can find directly size of the weld by subtracting minus 1.5 with thickness of the flat. So this is the for this we are having some small thickness, right? From that thickness, if you minus 1.5, we get size of the weld. So design strength, that is PD is equal to 0.7 into S into L effective length into FWD. So in this particular case, we need to find what is the effective length. So effective length, L effective length is equal to PD by 0.7 into S into FWD. This is the total effective length. Total effective length. So in order to find the single effective length, directly we can find by L effective length is equal to total effective length by 2. We get the effective length of single weld. So when a flat connected to a gusset plate, as shown in the figure, first step is size of the weld or size of the flat, that is B into thickness, that is breadth into thickness. The second step is tensile stress of the plate, that is Fi, Newton per mm square, that will be given in the question itself. Step 3, design tensile strength in the plate, that is B into T into Fi. The design tensile stress is equal to, we have to multiply with 1.5. Step 5, ultimate shear stress Fu is equal to Newton per mm square, it will be given in the question itself. Step 5, design shear stress, that is F suffix WD is equal to Fu by under root 3 into partial safety factor. You know, partial safety factor for workshop is 1.25. The weld connections are made in site, means 1.50 have to take. Or step 6, directly we can take size of the weld is equal to size thickness of the plate minus 1.5. Direct we can add here also, but directly I took here. So design strength is equal to 0.7 into size of the weld into L effective length into design shear stress in the weld. So total L effective length is equal to design strength by 0.7 into size of the weld into FWD. This is a total effective length of the weld. So in order to find single, we must divide with 2. So L effective length is equal to total L effective length by 2. That is the length of each weld which is done other side of the on the both sides of the flat plate. This is a very important question for your exam. This model is different from your previous model. This method is completely different from your previous model. Now let us solve example problem 1 on flat plates which are connected to a gusset plate. So design the fillet weld to connect a plate of 80 mm into 8 mm to a gusset plate, and the tensile stress in the plate is 150 Newton per mm square and the tensile shear stress in the weld is 330 Newton per mm square when the connections are made in workshop. So the size of the plate, first let us sketch the diagram. So this is the size of the plate, is given as this width is 80 mm and thickness is 8 mm. So in this case we need to find the size of the weld. Let this length be L1 from here to here, this length be L2. You don't know the effective length. The tensile stress Fi is given as how much? 150 Newton per mm square. So what is the first step? Step 1, given data. So what is given in the question? Size of the plate. Size of the plate is how much? 80 into 8 mm. Tensile stress, that is Fi, is how much? 150 Newton per mm square. What is ultimate shear stress in the weld? It is denoted with Fu, that is 330 Newton per mm square. What is partial safety factor given in the question? It is assumed that connections are made in workshop, that is gamma is equal to 1.25. So what is the second step? Step 2. Step 2, size of the plate. So S is equal to B into T, that is 80 into 8, so 640 mm. So answer is 640 mm. Yes, it is correct. Step 3, tensile stress in the flat or plate is how much? Fi is equal to 150 Newton per mm square, it is given in the question. Step 4, we need to find design tensile stress of the plate. sorry, the design tensile strength, that is 1.5 into B into T into Y. So 1.5 into 640 into 150. So what is the answer? So 1.5 multiplied with 640 into 150. What is the answer? Divided by 10 power 3. So 144 kilonewtons is the design tensile strength of the plate. Step 5. So what is step 5? Step 5. Ultimate shear stress. That is how much? 330 Newton per mm square. It is given in the question itself. Now, what is step 6? We have to find what we have to find in step 6. Step 6 is equal to design shear stress, that is FWD is equal to FU by root 3 into 1.25. So what is FU? FU is nothing but it is given in the question as 330 by root 3 into 1.25. Why did I take partial safety factor as 1.25? Because in the question it is given that the connections are assumed to be made in workshop. So 330 divided by root 3 into 1.25. So 152 Newton per mm square. That is a design strength and this is a design shear stress. Now we have to find L effective length based upon the formula. So I will write here. I will be writing here. Don't worry. So design tensile strength, that is PD, is equal to 0.7 into size of the well into L effective into FWD. FWD is nothing but ultimate shear stress, that is design shear stress. So this is the formula. So PD is equal to 0.7 into size of the weld into L effective into FWD. L effective is equal to design tensile strength by 0.7 into size of the weld into FWD. But we forgot to find the size of the weld. So what is the formula to find the size of the weld? You know, size of the weld S is equal to thickness of the flat or plate minus 1.5. So what is the thickness of the plate given in the question? I think 8. 8 minus 1.5 is equal to 6.5 mm. Approximately, for calculation purposes, it will be easy if you take 6 mm. So size of the well, I took 6 mm. The next point is L effective length. So L effective length is equal to what is design tensile strength? 144 kilonewtons. So 144 into 10 power 3 by 0.7 into what is size of the weld I took here? 6. So 6 into FWD. What is FWD? 152. 152. So what is the total L effective length? So 144 into 10 power 3 divided by 0.7 into 6 into 152. The total effective length is total effective length is 223 mm. 223 mm. So it is a total effective length. So now I have to find single effective length. That is L effective length is equal to 223 divided by 2. That is 223 divided by 2. 111.5 approximately 112 mm is the single effective length. With 1112 we have to do weld on both the sides of the plate in order to connect to a gusset plate. So these are the steps that are required to solve these problems. Is it clear?